7, lesson 8, just the last little bit here, just the part 2 of it. So again, we talked about the function on the previous page generally. Now we actually have functions to it. We're looking at our calculator about these functions and finding their zeros. So let's go ahead and do this. I'll do it with you here. We'll go to the calculator. So we got 3. That's the different one. We'll get to that one in a second. So I have it up here. So let's go ahead and turn this one off. Turn this one on. Okay, so this is what we should have. Okay, so that's what the graph looks like. Okay, so there's 2 solutions. It's bouncing. Okay, when you find those, you can find those with the zeros. So I'll just do one of them just for practice, and then I'll show you how to find the exact solution again, because it says exact. Okay, so here we go. Enter for left bound. Go over the hill. Right bound, hit enter. Top of the hill, enter. So 1.57. You can see that that's half of pi, but we'll just quit. We'll do the thing again. X, enter. Divide pi out. You see that it's 0.4997, which that's weird that it rounded like that. Oh, that's weird. I've never done that before. It's pi over 2. I'm not sure why I did that. I did 0.5 last class, but you should see the 0.499, see the 0.5. It's 1/2, so it's pi over 2. Okay, so pi over 2 is one answer. The other answer is 3 pi over 2. So the first section there for our solutions is pi over 2, 3 pi over 2. You didn't get it for that one either? So that's the solutions. Okay. What's up? Okay, I'll come look at it. 1 second. Okay, go ahead and try to put the second one in your calculator if you did get those 2. Try to put the second one in, and I'll pause the video. Okay, how do you put the square? Yeah, good question. So when you're putting these in, it's important to put the squares in the right spot. So you have to put the square around an extra bracket. So 3 sine x, and then see how I have a bracket here around the sine, and then square. Because the sine x is squared. You don't put it on the sine, you put it after the whole thing. Okay, yeah. What's that? I'm sure. just a second. And then you keep going here and add the -2. So let's look at my picture, and then you can see if you're right or not. What? What's wrong? Enter. So that's what it looks like. Okay, let's pause the video. Let's take a look at some. Okay, so you guys know how to find the 0, so I'm not going to go through find the 0 on these, but you can clearly see that there's 4 within our window, right? In terms of 0, 2 pi. So when you do these, it's pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Okay, so this one right here. Oops, forgot the 5 pi over 4, sorry. But 5 pi over 4. So those are the solutions for that one that had 4 bounces there. You can't get the fraction? Well, let's try it together one more time. Okay, let's just do whichever one that gives me here. Second, trace 2 for 0. All right, let's go left. I'm going to find this one in the middle. This should be 3 pi over 4 right here. 1 pi over 4, 3 pi over 4, 5, 7. I'm going to find the 3 here. So if we come down here, I'm on the left of it, hit enter. I'm on the right of it, hit enter. Get close to it, hit enter. 2.35, Sadie. See, I'm at 2.35. That's where it tells me 0 is. So I go second, quit, hit X, enter, divide by pi, 0.75. So we know that's 3/4. So that's 3 pi over 4.
Try the first one. Can you try the first one? Because I didn't get the first one.
Want to try the first one?
Yeah.
Sure. And sometimes they're finicky with that. Like we just had one that happened. That hadn't happened to me before either. So I'm not saying it works every time, but you should, when you get the 0.499s, whoops, that's not going to help us there. All right, 5, number 2 for 0 again. Let's go with the first one. All right, so I'm on the left. Enter. Whoa, way over there. Enter from the right. Enter. get close to it, enter. Okay, second, quit, x, enter, divide by pi. That's what you got? Yeah, that one didn't work for some reason. It is pi over 4 though. So what is pi over 4? Let's see here. Pi over 4. Why is it 0.30?
Figure that out on a test. I mean, maybe if you were able to determine like the middle two, you'd be able to figure out.
Oh. I know why. I know why. Okay, because 1, 2, 3, 4. So it's actually because, do I have on my right window? Yeah, I have the right window on. Let's see here. Cool. Okay, so we were going to get to it in a second with algebraically. So the problem is that Jake saw that he got 0.955 there. That actually is an answer. We're going to find 4 more algebraically. It looks like it's bouncing, but if you look closer, it's actually going through twice. So there's 4 answers that are nice, easy radians, and then there's 4 answers that are numbers. Did you get it?
I got 0.78.
Yep. So then he moved over a little bit farther. So this one there is 4 other answers. So it's just kind of like going back and forth. They are tricking us a little bit, but we'll do it right now. Okay, is it a hoax? Yeah. The exact values we should get, though, the ones that we see were pi over 4, 3 pi over 4, I missed it again, 5 pi over 4, and 7 pi over 4. I don't like 5 for some reason. Okay, we're going to verify algebraically, where this is actually kind of interesting to me because we are going to go ahead, see how this, we have a negative cos 2x, and then we have a 3 sine squared minus 2. So this is already factored, essentially. We want to know when cos 2x is 0, and we want to know when 3 sine squared minus 2 is 0, sine squared x. So we're kind of solving those 2 pieces. Here's the thing. Let's just ask ourselves in general, when is cosine 0 again? Good. At pi over 2 and 3 pi over 2. But it's 2x, right? So what do we do to those values? You divide by 2. What's pi over 2 divided by 2? Pi over 4, which we got, right? 3 pi over 4. And it continues. And now if you're saying, why are you doing 5 pi over 2 and 7 pi over 2? Well, because we know how many cosine curves are going to happen in 2 pi when it's 2x. 2 of them. So I'm getting I'm getting a list of 2 curves and dividing those by 2. And dividing those by 2 puts us back in our range, right? What's up? Negative's irrelevant. Negative times 0 is 0. Yeah, so the negative doesn't affect anything here. Okay? Because we just want to know when cos 2x is 0. You're breaking down. Just hang in there. You're getting weary. Okay, so this one. True. Just add the 2. We're just doing algebra here. Square root. So sine x equals root 2 thirds. And it's plus or minus. No, because we're going to calculate. So my question to you first is, we know, did you guys know this? Maybe you don't. Any value between 0 and 1, sine can be on the unit circle. So sine starts here, and it's 0, and it works its way around a circle to 1, hitting all possible values. So like this right here is 0.8, 0.2, right? And so we're going to sine inverse root 2 thirds to get the reference in radians. Because is root 2 thirds on our unit circle? No, so we're getting a radian that's uncomfortable. We're getting a radian that's not nice and easy. That's okay. So sine inverse of negative root 2 thirds. Can somebody do that for me? You probably saw that number before, Jake. 0.49? Yeah. Are you in degrees again? You are? It should be 0.955. Should be sine inverse of square root 2 over 3. But that's what we saw, remember? 0.95 was that graphing point that we didn't like. Okay, so this is what I want you to know. 0.955. Can anybody tell me about where that's going to be if I drew that slice? Good. It's going to be right here. Because right there's 1, right? 0.955. So this is what you're looking for. We're finding the 4 values because it's plus or minus. Here, here, and here. We're looking for those 4 spots. How do we find those? So here's one answer. Close, not 1 plus. So it's going to be, remember, for here, right, it's going to be pi minus it because it's pi there. We don't go from here for reference, say. We go from here. It's always the x-axis. So to find the second one, we're going to go pi minus it. That's the second one. The third one, we're going to go pi plus it. And then 2 pi minus it. And those are going to be your solutions. They said round the nearest tenth, so this one actually rounds to 1 for the first one. Yeah, they put 1.0. 2.2, 4.1, and 5.3 are the other 4 solutions. Okay. Okay, I'll come help you get yourself. All right, we'll stop the video. That's all for finishing that out.